So just very briefly, I've been with Arrow now a couple of years. Arrow's the world's largest global electronics distributor. You might be thinking, why is a distributor, a company that sells components, talking to you about security? What's our expertise? We actually have about between 3,500 and 4,000 engineers throughout the world who are doing engineering services and design services to support our customers. And one of the biggest things that we're helping our customers with at the moment is security. So what I'm going to give you now is an overview of the work that we're doing and the challenges that we see people facing, in the hope that the challenges you're facing are similar and that this can help you move forward. There's no other adverts throughout the talk. Okay, so I've kind of broke it down a little bit more the way I like to talk. So what we're going to do is we're going to look at where cybersecurity has to be applied, why we have to do it, what it actually means, when it has to be done by, and then how to do it. So where do we need to apply cybersecurity? So if you've been following the CRA at all, the definition of where we have to apply cybersecurity for the CRA is any device that is connected. Now, connected isn't actually defined, and so most people are taking that to mean it's connected to the cloud, right? Wireless or Ethernet. But that's not necessarily what it could mean. It could mean Bluetooth. It could even mean connected in an enclosed environment, like you could be running a lab with your own devices in your own network. It's still a connected device. Connection does not mean the cloud, and it doesn't mean connected to the outside world. So you have to be very careful that your product could fall into these categories. There was a reason why on my first slide, go back, I showed an engine. So this is actually a electronic transmission inside an EV. It is classed as a connected device because the way the controller for this talks to the rest of the vehicle is through an Ethernet style connection. So I think most of us were kind of expecting that it would be, consumer electronics. That's where most people are thinking the CRA applies. But if you design anything with a microcontroller, a microprocessor, GPU, MPU, FPGA, the chances are it could be classed as connected, so please do check. So what happens when security goes wrong? It can be devastating. There's lots of stories you can see in the press about what happens when it goes wrong. However, there's also a lot of really small things that go wrong when you get security wrong. But all of them can have a large impact to your business. When it comes to CRA, I'm sorry, I should say, so the CRA is the Cyber Resiliency Act that's in force in the EU. Other regions are enacting similar standards. And so one of the things now that can go wrong is you can actually fail to comply with the regulations, and the fines for failing to comply are in the region, I think, of 3% of your turnover. Okay, so what does the landscape look like? So today I'm primarily talking about CRA. However, as you can see, there are a number of additional regulations which cover very similar topics. And so if you're designing products for the EU, you have to be aware. If you're designing products for other markets, I would still highly recommend that you take security into consideration, because this regulation space is rapidly changing, and things which aren't regulated today, I predict, will be regulated in the near future. Okay, and here's just an overview of the penalties. I was wrong earlier. It's 2.5% of your revenue for CRA, and 4% of your revenue for RED. These are numbers that will cripple businesses, and the reason they're so high is because enabling security is complex and difficult. At the moment, the estimate is there's something like 18 billion connected devices, and by 2030, there will be 40 billion connected devices. We do not have the design engineers today to design security into 18 billion devices. The population of design engineers that are experts in security will not grow faster than the number of devices will grow. By 2030, with these 40 billion expected devices, we will not be able to add security after the fact. Okay, so this is the timeline. And you can see that this is pretty much next year from where we sit today. And then the 11th of December is the year after that. So in total, we now have less than 2 years, like 18 months to sort this out. So as an electronics industry, we have 18 months to solve the CRA problem. And the way it's monitored, and this actually was a surprise for me when I first heard about it, is it's monitored through the CE mark. As a company, you will not be allowed to CE mark your devices for sale in Europe unless you sign that they are compliant to CRA. And that may be common knowledge. For me, when I learned it, I was like, wow. I mean, I knew there was a CRA and that we had to comply with it. I didn't realize that compliance also was tied into using the CE mark. And you know that if you can't CE mark your devices, you can't sell your devices. Okay, so now the how. Sorry, just excuse me one moment. So if we look through the journey from where we are today with the product that's pretty much designed or in the design stages, right the way through to having your certification, you can see we go through a number of steps. So security concept, this should happen at the design stage. You then go through a gap analysis. Again, these steps you will recognize as being quite similar to other design practices that we follow, because let's not do things differently if we don't have to. We'll then go through the gap analysis. We'll then go through the implementation itself. You'll be pleased to know that this half-hour talk isn't going to turn into a 2-day workshop on how to do secure Linux. But if you are interested in that, do reach out. From there, we then go to initial in-house testing. We do a risk assessment about where we've got to and what we've got left to do. And then finally, we can look at third-party audits. Now, because the CRA is tied into CE, you do obviously have the option of winging it, right? So if you have a CTO or an engineering director at your business who doesn't mind the risk of going to jail and is okay with huge fines, you can sign this off, right? And you can say, this is good. You don't have to do third-party audits. My recommendation is that you consider doing third-party audits because, as a responsible design engineer, as a responsible head of an engineering organization, you should do your due diligence and make sure you're correct. Okay, I'll just leave this up for a second for you to kind of absorb it, and then I'll talk through it. Okay, so when we're looking at security and CRA, let me jump out of your way. Although these are available afterwards. So we've got different zones, okay? So zone 1, so this is, let's call this, the internet or the cloud, PC, laptops, network switches. That's not what we're looking at, okay? Zone 2 is where most of us are focused. So I've used the term here MCU for a microcontroller. Could it just easily be a microprocessor or any other form of embedded CPU, an FPGA, even an FPGA if it doesn't have an embedded SoC. Anything that can run an algorithm, let's say, okay? And now the bits that we're interested in, and this is the bit that we kind of expect. You've got some form of processor. It talks to the internet. That is of interest, okay? That is what we think of with CRA. But like I was saying earlier, it's defined as connectivity, not internet connection. So a bog standard little UART, and if you're like me, you probably still design your UARTs with resistors so that whenever you realize you've got TX and RX the wrong way around, you can still swap it over because you never get it right. That, if you've only got a UART connectivity, it's still a connected device. Okay. On your product itself, if you've got an MCU connected to a microprocessor, and the microprocessor, say, running Linux, and your MCU is running RTOS, and they talk to each other, that is a connected device. And now this is where it gets crazy. I mean, I think that's obvious. I think most of us can kind of understand why this might apply, like your connection to, to flash and to sensors and things that are external. However, I wouldn't have considered this. Okay, the Zone 3 SL1. If you've got a PMIC, a programmable PAR chip, that's a connection from your processor. I mean, I personally would never have considered that when I was looking at CRA initially, that how I talk to my PMIC is important. How I talk to my LED driver, how I talk to internal sensors. This all falls under CRA. This is all a part of connectivity. Anything that your processor talks to can be on your PCB, inside your box. And to me, this is the bit that I think will catch out a lot of my customers. This is the bit that worries me, because I think most people will say, it's all right, I don't connect to the internet, I'm cool, I can see you marking off I go. And then they're at risk. And so one of the things I want to try and get through here is just how broad these regulations are. Yeah, of course you can.
You mentioned microcontrollers and microprocessors.
Yes.
Would it still count as connected if you had something like one of the STM32 MPs that has an ARM, an A series and an M series?
Inside one device? So my understanding is that no, that doesn't class as a connected, because it's inside. I mean, it should, but my understanding is it doesn't. It's one of those things. So basically the question, for those that didn't hear it, is I've talked about having a microprocessor and a microcontroller on a board with physical wires between them for communication. Lots of devices have either multiple Cortex-Ms or Cortex-Ms and Cortex-As in the same device, and those two processors inside the device talk to each other. A device is considered a box. And so if you have, so even really complex devices that say like an NVIDIA Jetson or something like this, where you have multiple controllers, multiple GPUs, that's classed as a device, and it's only if something exits the device that CRA applies. If I'm wrong, let's talk later.
No, I'm just thinking things through.
Yeah.
Raspberry Pi microcontroller has flash in the package over SPI, but they still break the chips, the pins out.
If it's accessible from outside your device and you connect to it,
well, in this case you wouldn't.
Well, then it's not. So basically, so the question is, if you have a device that has external pins so that you could connect to it, but you choose not to connect to it, is that covered? I'll give you a provisional answer, which is my belief is no. But let's have a proper analysis of that, because I don't want to give you an authoritative answer when I'm not 100% clear. My understanding is that if it's not connected to, then it's not classed as connectivity. But let's actually review that together afterwards.
So the idea, if you can connect to it somehow, then we need to consider.
Yes, that's right. Yeah. So I don't want to go through this in detail, primarily because of the time we have. But what I'm kind of showing you here is how you would set up some threat modeling. And really, the idea is that you just plan how you want to run your threat modeling. Define the protocols, and like I said, the protocols include all connectivity, any way that you can connect to your device. So that includes things like UART and flash. You can then run your threat models. There's lots of open source threat models. I'm a huge supporter of the open source community. I think that when things are open and available to be inspected, they generally are better. And of course, what's great is if they aren't better and you know that, you can fix them because it's open, and then you can then submit your work. So you can think of open source as like the modern peer review journal, where everything that you publish is open to inspection and therefore open to improvement. And personally, I think that is, that's a huge gift to our community of designers. And And as a sort of like a side topic, if any of you have came across open source hardware, again, if you've got some spare time, I highly recommend you get involved in these projects. It's a great way of giving back and bringing up the young engineers of the future and helping developing countries that don't have the embedded design infrastructure that we're lucky to have here in the Western world. Okay. I've seen VAPT wrote down so many times without any explanation of what it stands for, so I thought I'd actually put it on the slide. Apologies if you all know and I didn't when I was first looking at this. So vulnerability and penetration testing. So again, this is like considered like maybe like the sexy part of cyber resiliency, which is actually doing the analysis and doing the initial, can I actually attack and break this device? Really, if you're relying on this to tell you that you're broken, you've started your security too late. When fundamentally, when we look at how you support, how you create secure designs, make sure that what you're running is what you think you're running. Step one, so that is your secure boot, your signed code, all that good stuff. I mean, I say that's one step. Obviously, there's a whole host of information around there, but make sure that what you're running is secure, and make sure that the resiliency comes in from making sure that you can securely update when you realize that what you're running needs to be different. So secure boot, over there updates. Those are the two main topics that will give you secure designs. Okay. So now let's look at our maturity assessment framework. So this is a way that we can look and consider how much effort we need to put into our new product security design based on the information and understanding that we have of what we've done in previous products. So just to kind of like highlight a couple of points, security can't sit purely with your embedded software engineers, and it can't sit purely with your hardware design engineers. Whenever, if you think of like modern design processes where maybe you have like an agile process and you've got scrum masters and you've got stakeholders and you've got people from product management, giving you functions and giving you things that they want put into the product. All these good modern design methodologies that we have. If you put security on your agile board, the chances are most of your software engineers and most of your design team will say, yeah, that's going to be like 12 to 18 months. Because if you haven't done it before, understanding the complexity of the secure elements inside the processors and devices that you're working with, it's a huge undertaking. And today, the reason we are where we are, the reason there's so many people giving you these sort of talks at this event, is that people have looked at that 12 to 18 months and thought, yeah, I don't want to spend that time budget today. And so they haven't. But we're now at the stage where if it's not done in 12 to 18 months, you can't release your product. And that's where the panic's coming from and why there's so many people talking about this today. So the problem that I see us facing is that most products aren't secure. And using the secure elements that are inside your devices or adding secure elements now is difficult and time-consuming. And if you think, well, the way to solve that is I'll just reach out to some external contractors who are expert in it, unfortunately, a lot of other companies are also reaching out to them. And so a lot of the ones that are proficient are already booked. And so, the key message now is that you need to look at both the products that are pre-designed and the ones that you're designing and work out a method that will apply to all of them. And so let me talk about kind of how you can do that. So if I was designing a product today, knowing what we know about where CRI is going to be, you would look at the processor that you pick. Now, as you know, I work for Arrow and we represent lots of different suppliers. But I can tell you that all those processors will have a secure enclave inside it that will provide some level of security that you need. But the chip itself isn't secure unless you use security elements in it. And I know that sounds obvious, but it's almost worth repeating because you can't buy security. Okay, you have to design security. So you can buy processors and FPGAs that have security features, but you have to understand and use those features correctly for your product to be secure. And now, if you are designing across a wide range of different products, you may find that every product does it a different way. It's not a may. You will find that every product does it a different way. They offer different features. They offer different functions. They call things by slightly different names. And so one of the ways that you can solve this problem, if you're sat today with a range of products already released in the field that you want to keep selling in a couple of years' time, is to look at having a common solution across all of your products. Now, having a common solution across all your products is not BOM, so bill of material, and cost efficient if you were doing it from today. Because by putting the same thing in each of your products, instead of making use of the feature set, the individual tailored feature sets of each of your processors that you're using, that's a less efficient way of doing it, right? Because you're adding an extra device, and so therefore you're adding extra cost. However, if you have multiple products and you're paying once to understand a new device and then using that device in lots of different applications, that could be a way forward for you. So what do I mean by that? Let's say we have 4 products. One has a ST microcontroller, like you mentioned. One has an NXP IMX9. We've got another product that has a Qualcomm Dragonwing, and maybe we're running a final high-end AI product with an NVIDIA Jetson. The way, as a design engineer, I would love to secure those is to understand the details of what ST offers in there in Secure Enclave and do the best possible, most efficient job using that, and to do the same for the Dragonwing, and do the same for the NVIDIA Jetson, and do the same for the NXP microprocessor. Unfortunately, most of us don't have the luxury of sufficient embedded engineers to learn all of this and apply all of this between now and December 2027. So a solution would be to add a secure element that you learn and understand. There are lots to choose from. I'm not going to recommend a particular one because there are so many, but if you want to talk to us for recommendations, we're happy to talk to you. But a solution would be to pick a secure element, learn how to use that, work with a common platform. And again, there are multiple different platform companies that can help you do this. We don't own any of them, so any recommendations that we would give you on which one to use would be based purely on your working relationship with them and us trying to help you out. However, I can't give this talk without giving you pragmatic advice on how to solve the problem. And the pragmatic advice, if you have multiple products, is pick a secure enclave, pick a platform provider, and put the two together and roll them out in all of your current products that you're currently developing. That will then give you the time to consider for your future products, do you want to do it in a more BOM efficient way? And when I'm talking about these secure enclaves, we're talking about in small volumes adding maybe £5 to the cost of your design, which if you're in high volume is a lot. Obviously, high volume prices will be different. And to me, I almost don't like the solution because it's not as neat as using the features already inside the processor that you have. But it does allow you to resolve this problem across all of your products for one opportunity cost. Because often when we run engineering departments, our biggest cost, well, not often, always our biggest cost is our team, right? Both our team working on the cost of the team itself, but also the opportunity cost of the fact that they're not designing something new. Okay? Because the problem with security is it's not a feature that anybody cares about. It's just a feature that we must all have. So saying that your product's secure come 2027, well, that just allows you to sell it. If it's not secure, you're not selling it. So it's a must-have, but it's not something which people think, oh, well, I'll buy it because it has that. And therefore, it's hard to justify the cost of doing it, which is why we are where we are today, because nobody has justified that cost. But going forward, we have to bake the cost in. And so as a pragmatic solution, if you've got lots of products, that would be my recommendation. And like I said, if you want to come and talk to us, I'm at the show for 2 days. I'll be in J1. We can also introduce you to some partners. that can help you with your choice of secure element and your choice of security framework, which will enable you to meet these requirements with as little design effort from yourselves. It's not the right solution for everyone. If you have the people and the time, do it the neat, efficient way. If you need to solve the problem quickly, that would be my recommendation for a way forward. So with that, I would like to say thank you. We're pretty much at time. However, this time I have actually finished early enough to take a few questions actually on the stage without having to run away. Sir?
Just to clarify the point.
Yep.
Two products connected very closely to each other with like UART or Canvas.
Yep.
Based on the
So the question was two products who are physically close to each other, connected with UART, do they need to be certified? Yes, even if they aren't connected. So if you just have one product with a UART port, it needs to be secured. Yeah, it's like, I know. Sir?
Does what I would say common sense come into this? Like, for example, if you've got something with a microcontroller in it and it's got a UART Modbus interface or something, but the processor in there, you can't change the firmware in it. You can't alter the code. It's just like maybe you have to take the thing apart and JTAG in, or maybe even in the limit change an EEPROM or something. In that case, wouldn't certifying that just be pretty trivial? You just say, well, it can only run the software that it's intended to unless someone physically takes it apart and reprograms it.
Yep.
Would that be a pretty simple thing to just say, well, we don't have to worry about this because...
So the answer is kind of yes and no. So yes, you can be pragmatic. Yes, the certification will be simple, but you can't not worry about it. You still need to generate the documentation that says, this is my design. I have analyzed this design. This design runs from EEPROM. From what I think you're saying is that your design will not be upgradable in the field, which you will then have to justify, because you'll have to justify this thing will not be upgradable. Therefore, if there is a problem with it, are you going to like recall all your devices? It's just something to think about. But if that's the direction you go, then you can say, this is the analysis I've done. I've looked at these interfaces, and my decision as the product owner, the CTO, the engineering director, is that it meets the CRA. Okay, and so that's what it applies for actually everything, no matter how complex it is. At the end of the day, it's for you to justify that your product is secure. And the easiest way to justify, if you'll excuse the expression easy, is external testing. But you don't have to do external testing. And like you're saying, you'd be very pragmatic. Do you have to worry about it? Yes. So I'm kind of answering your question with multiple bits, right? The bit, do you have to worry about it? Yes. Do you need to do some form of analysis? Yes. Do you necessarily have to use secure enclaves and write a lot of security code? For your particular use case, the answer may be no, that you don't need to do any of that. But you still need to have gone down the path to arrive at the decision that you don't need to do it. And you need to be able to back that decision up, potentially in court.
One
Yeah.
question related to that.
Yeah.
Going back to my example, you have a product with a UART board.
Yes.
And let's say the existing firmware on that product does not support any communication on that board, but the product can be firmware flat, basically, in the future. Do I need to work?
Yes. Yeah. So the question is, if you don't have connectivity today, but it's upgradable, do you need to worry? And the answer is yes. And the worry is that you have to go through the process. Sorry, am I out of time? Okay. Yeah. So you still have to go through the process of saying, this is what I've looked at, and these are the decisions I've taken to make sure that what I've done is secure. I would say that if you've got a product that can be updated, then you should be looking at secure boot and that's signing your firmware as a minimum. Okay, thank you so much. It's been great talking to you. Like I said, we're in J1. It would be great to talk to you further. Thanks so much. Take care. Ciao.